Assalamu alaikum students. I hope so. You are doing well and you are enjoying your good health. And I am also expecting from you, you have well understood the previous lecture and you have done the practice of that. Now students, today we are going to start our new exercise, that is exercise number 1.4. And in this exercise, we are going to have a new topic. In the previous exercises, we have discussed about the matrices and different types of matrices, and then the operation of addition and subtraction in that topic. Now, the new topic is there, how we can multiply the different matrices and what is the possibility for the matrices to be multiplied. So friend, first of all, before starting the topic, we must know which type of matrices can be multiplied. Like in the subtraction and addition, we have discussed which type of matrices can be added or subtracted. Yes, this is the order. If the order of the matrices is same, then you can say that they are conformable for addition and subtraction. Now the product is there. How we can find the product or when the product is possible? First of all, we will check the possibility. Which type of matrices can be multiplied? Okay. For this purpose, students, if I am having a matrix A which is having entries 1, 2, 3 like this, and then matrix B which is having the entry like 1, 2, 3 and 4. Okay. Students, if the possibility is there, if the number of columns of the first matrix, if I am going to find the product A, B, then A will be called as the first matrix and B will be called as the second matrix, right? Okay, now if the number of columns of the first matrix is equal to number of rows of the second matrix, right? If number of columns of the first matrix is equal to the number of rows of second matrix, then you can say the possibility is there for taking the product. Okay, check the number of columns in A. How many columns are there? Yes, this is one. Number of columns of first matrix should be equals to number of rows of second matrix. Okay, now tell me how many number of columns are there? Obviously this is one column. And how many rows are there in B? 2. So 1 is not equals to 2. So there is no possibility to find the product of A, B. Now you can also check the product BA. Now we are going to check the product of BA. BA means now the matrix B is the first matrix and matrix A is the second matrix. Now we will check the number of columns of matrix B. First we will check the number of columns of the first matrix. Now this is B and second matrix is A. So now number of columns of first matrix are 2. And number of rows of second matrix are 3. Again 2 is not equals to 3, so product is not possible. Now students, I am taking another example. Now I am having the matrix A like this and B like this. Again the same rule is there. For the first matrix, we will check the number of columns, and for the second matrix, we will check the number of rows. You will check the first or second matrix from the product. If you are going to find the product A, B, then A is the first one and B is the second one. Okay, now check the number of columns of the first matrix. How many columns are there? 1 and 2. 2 columns are there. And now check the number of rows of the second matrix. That is 2. Now we can find the product A, B. Product AB is possible. Now friends, we will check the product BA. BA. It's mean what is the first matrix, that is B, and the second one is A. Now we will check the number of columns of the first matrix, that is B. How many columns are there? Yes, there are 2 columns. So 2 columns are there. And how many rows are there in second matrix? 1, 2 and 3. So 2 is not equals to 3. So we can say BA product is not possible. Now students, from this conclusion we can say the commutative property is not possible. Means it is for the commutative property always BA is not equals to AB. Now we will discuss the commutative property. What is commutative property? Students, this property you have discussed in the previous classes as well. Now the commutative property. Okay, this is commutative property with respect to multiplication, right? In the previous exercise we have discussed the properties, but it was commutative property with respect to addition, and it was possible, means A plus B is equals to B plus A. But now we are having commutative property with respect to multiplication, and you know, for the matrices we use capital alphabets. So AB is not equals to BA in general, means it is not much that always you will get AB equals to BA. Sometimes it can be equal, sometimes it will not be equal, right? Whenever you have to write the commutative property, you will just write the statement commutative property with respect to multiplication does not hold in general, means always you will not get this statement AB is equals to BA. Sometimes it is equals or sometimes it is not equal. Okay student, now this is your exercise 1.4 and the question number 1 is which of the following product of matrices is conformable for multiplication. In this question just we have to tell the product is possible or not. No need to multiply them, right? We will just check their possibility. Now check in part number 1, number of columns of the first matrix are 2 and number of rows of second matrix is also 2. So the product is possible. Now in part number 2, check the part number 2. How many columns are there? 2 columns. And in second matrix, how many rows are there? 2 rows. So product is also possible. Now check this part number 3. How many columns are there in first matrix? 1. And how many rows are there in second matrix? 2. Now number of columns of first matrix is not equal to number of rows of second matrix. So product is not possible. Now the part number 4 is there. In this part, how many columns are there in first matrix? 2 columns, and rows are also 2 in second matrix. So the product is possible. The last part is part number 5, in which you are having 3 columns in the first matrix and 3 rows in the second matrix. So product is also possible. Now student, there is question number 2. You are given matrix A and B and we have to find the product AB and BA. Firstly, we will find the products, and we have also in the question if possible, means you have to check both the products are possible or not. You have to check, right? So we have to write the answer product is possible or not. If possible, then why? If not possible, then why? We are going to solve this question on the board. Okay student, now this is question number 2 and we have to find the products AB and BA if possible. So first of all we have to write the possibility. If yes or if no, then we have to justify our answer. So first of all we will check about AB product. In AB product, first matrix is A and second matrix is B. So we will check the number of columns of A, it is 2, and number of rows of B, it is 2. So product is possible. We have to write the statement as number of columns of A equals to number of rows of B. So product is possible. Okay, now we will find the product. How to find the product? Okay, for A, B, we have to write first matrix A, 3, 0, minus 1, 2, and the second matrix B, 6, 5. Just we have put the values of matrix A and B. Now students, we will start multiplication. How we will multiply the matrices? For multiplication, first of all, we will select the first row of the first matrix. We will select the first row. Remember this point, for multiplication, we will select the first row of the first matrix. Now we will multiply this row one by one with every column of second matrix. We are having only one column in matrix B, so we will multiply it with this column. If we are having more columns, then we will multiply this row with each and every column. Then our row will be completed. Okay, now how we will multiply? We will multiply the first entry with the first entry, 3 multiplied by 6, and second entry with the second entry. Okay, now as no more columns are there, so brackets will be closed. Okay, now we have multiplied the first row with the first column. So the first entry will be multiplied with the first one and second with the second one, and they will be combined with plus sign, right? Then your first row will be completely multiplied with the first column. 3, 0 is in the first row, and 6 and 5 is in the first column of the second matrix. Now it is completely multiplied by multiplying 3 into 6 and 0 into 5 and combining with positive sign. Now as no more columns are there, so first row is completed. Okay. Now we will take the second row. Similarly, second row will be multiplied by each and every column. Minus 1 will be multiplied by 6, minus 1 will be multiplied by 6, and 2 will be multiplied by 5 with plus sign. Remember one point, row will be multiplied by column will give you a single entry. Single entry, how single entry? You can see this is 3 multiplied by 6 is 18, plus 0 multiplied, it is multiplied, plus 0 multiplied by 5 is 0. This is minus 6 plus 10, and what will be the answer? Answer will be 18 and 4. Now you can see there is a single entry. We have multiplied this first row with the first column and we are getting a single entry. Second row with the first column, we are getting a single entry, right? So complete the row with the completely multiplied the first row with the first column, right? You have to put the plus sign. If you are not putting the plus sign, then your complete question will be wrong. Okay, students. Now the next part is BA. You have to write the same statement as I have told you in part number 1. Now I am just checking and I am telling you the product is possible or not. Now the first matrix is BA and the second matrix is A. Okay, now check the number of columns of the first matrix. It is 1, and number of rows of the second matrix are 2. So 1 is not equals to 2. The product is not possible. Students, you have to write the same statement as I have told you in part number 1. Product is not possible. Clear? You will write the statement as number of columns of the matrix B is not equals to number of rows of matrix A. So the product is not possible. This is your question number 2. Now student, this is question number 3. Find the product. Students, I am going to do the part number 3 because part number 1, 2, 3 and 4 are same. You can do the rest of the question with the same pattern I am going to tell you. I am going to do just part number 3 and then I will do part number 5 from question number 3. Okay, with the same rule we will find the product of this matrix. Now the question is find the product. Obviously the product will be possible, that's why they are saying find the product. If not possible, then they will say you check the possibility. It's better to check the possibility. How many columns are there in first matrix? 2 columns. And how many rows are there in second matrix? 2 rows. So we can multiply them. Okay. And what is the method I have told you to multiply the matrices? We will take the first row and we will multiply it with the columns in the second matrix. Now we are having just one row and the one column. So we will multiply this row. Minus 3 will be multiplied by 4 plus 0 multiplied by 0. Clear? Now we are not having any more rows and columns. So question is completed. Just we will multiply them. This will be minus 3 multiplied by 4 minus 12 plus 0 multiplied by 0 is 0. and this will be a single entry. And I have told you that when you will multiply a row with the column, you will get a single entry. Okay. Now students, this is question number 4. I am not doing the part number A, which is same as we have done part number 5 of question number 3. Just entries are changed. Now in part number B, look how many columns are there in first matrix. It is 3, and rows are also 3 in the second matrix. The product is possible. Question is same, find the product or multiply the following matrices. Okay, now with the same rule, we will select the first row and we will multiply this row one by one with every column in the second matrix. So 1 will be multiplied by 1, plus 2 will be multiplied by 3, plus 3 will be multiplied by minus 1. Okay. Now first column is completed. After some gap, we will multiply the first row with the second column. 1 multiplied by 2 plus 2 multiplied by 4 plus 3 multiplied by 1. Okay. Now the first row is completed. Now we will solve the second row. 4 will be multiplied by 1, 5 multiplied by 3, 6 multiplied by 1 is 1. Why? Because we are going to multiply this row with the columns, every column in the second matrix. So 4 will be multiplied by 1 plus 5 multiplied by 3 plus 6 multiplied by minus 1. Okay, first row column is completed. Now second column, 4 will be multiplied by 2 plus 5 multiplied by 4 plus 6 multiplied by 1. Okay, now we will just solve this. 1 multiplied by 1 is 1, plus 2 multiplied by 3 is 6, plus 3 multiplied by minus 1 is minus 3. It is minus 3. 2 multiplied by 1, 2, plus 2 into 4 is 8, plus 3 into 1 is 3. This is 4 plus 15. 6 multiplied by minus 1 is minus 6. 4 multiplied by 2 is 8 plus 5 into 4, 20 plus 6. Okay. Now this is 1 plus 6 plus minus minus 3. 4 plus 15 plus minus minus 6. Okay, now 8 plus 2, 10, 10 plus 3, 13, 20 plus 8, 28, 28 plus 6, 34. Okay. Okay, now this side, 6 plus 1, 7, 7 minus 3 is 4, 15 plus 4, 19, and 19 minus 6 is 13. And this is 13, 34. This is your answer.